Unit 17, Part 8. We're up to Section 3 of Klenk's text, starting at 324, on quantifier negation. So the principle is still the same. Okay, important thing that Klenk says in opening this section. In applying the quantifier negation rules to multiply quantified formulas, the procedure is the same as before. And you see the way she presents, top 324 here, presents these equivalences, right? In terms of phi, right? The Greek letter phi, which stands for any formula, simple or complex. Okay, so that is the same as before. And as I'll now show you, the everything changes from left to right, everything changes from left to right, from one formula to the other. That is, three things change from left to right. That's going to hold for these multiply quantified formulas as well. The only new complication that you need to be aware of is basically that you have to grasp, for example, this thing, right, which is what this here negated quantifier, or without negation, what this quantifier quantifies over is this whole thing there. That you have to grasp as a substitution instance of the phi in that formula. You have to grasp that as a subformula, right? So look what happens in this one. So this is me running through the example 1 of the 4 examples she gives on 324. So I've got the first 2 lines of 1 here, and then she goes to this one. I've got that up on the board as well. And then she introduces these, the other forms, which are, yes, we have 2 other forms of the rule down here. I'm going to speak of those when I go from here to here. Okay, so look what happens here. So QN, quantifier negation equivalences. So remember them from Unit 11, and then at Unit 11 we had the QN rules, Unit 12 the CQN rules. You were reminded of them especially in Unit 15 when we went over proofs in monadic predicate logic, because they're very important in doing proofs, and that's really the thing that she doesn't mention here that is really the crucial context for why you will be using these, right? You will be using QN rules here. More often than not, you'll be using them in proofs in order to get things in quantifier form, right? And when she says at the bottom of 324, if you use several applications of the QN rules, you can run a negation through a multiply quantified statement from the beginning of the formula to the final function. Run a negation through, right? So that's these ones here at the bottom. See what she means here by running a negation through from there to there to there. So the negation goes from the beginning, right? Negates the overall form, so it's a negation here, and then here that negation after several applications of the QN rules goes to in front of the propositional function. You're doing that because you first of all you want your first formula to be in quantifier form, of course. Why? Because, as I've repeated ad nauseum, only formulas in quantifier form have the instantiation and generalization rules available to them. So only if it's in, so we will be doing, so when we transform from here to here, this is a universal statement, right? And you will be able to universally instantiate on this formula, right? UI, and it will be involve, I gave you a taste of UI in the part 1 of Unit 17 when we glanced ahead at page 342, where you have that proof of the argument that we couldn't prove valid using the resources of monadic predicate logic. And we'll see proofs soon when we get to Unit 18. But when we do the proofs, you will be universally instantiating, and it will involve dropping this quantifier, dropping this variable everywhere it appears, and replacing it with a constant, a, usually, the individual constant a, but leaving the y's in place. But that is it. This will be a UI, right? So you will be able to universally instantiate, say, on this, whereas you won't be able to on this. So you can't do EI on this. You might think you could do EI, why EI, because it's an existential. Quantify here, but it is not an existential statement, it is a negation. You want to get from negation to quantify form so that you can UI. Okay, and maybe you want to do the same thing if you're working backwards from a conclusion, which is a negation. You want a QN to get that in quantify form, so maybe you can use a generalization rule on that. Okay, so that's should be very familiar from all the proofs in monadic predicate logic stuff, right? And you guys are Top Gun, so you would have mastered that pretty well. Excuse me. So that's why you're going to do it. And also this thing about running through the negation, which from the bottom of 324, right? So you end up with something like this. Why would you do that? Because why would you want to do that before you start instantiating? Because if you were to UI, universally instantiate, on the formula in this form, the result would not be in quantifier form. The result would be negation, there exists a y, negation, F-A-Y. F-A-Y, right? So you've got rid of this. But you wouldn't have, the result would not be in quantifier form. Whereas if you run the negation through, so you've got, right, quantifier, quantifier, propositional function, or maybe if it's three place, quantifier, 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 negation, propositional function, say, then the result of instantiating will be in quantifier form, so you can instantiate that again, right? And maybe even again. Okay, so that's why you want to run it through so that the formula is nicely all set up for possibly multiple instantiations. Okay, so let's look at the transformations that are the QN rules. So here I'm going for there does not exist an x such that there exists a y such that x does not fy, right? I'm saying fxy, x f's y. There does not exist an x such that there exists a y such that it's not the case that x f's y. Okay, so that goes to this. For all x, not the case. There exists a y such that x does not fy. So look at what changes here. Again, 1, 2, 3 things change. Remember what they were. It was if the quantifier is a universal on one side, it becomes an existential on the other side. That is, the quantifier changes. Right? Goes from existential to universal or universal to existential. Quantifier changes. If the quantifier is negated on one side, it becomes unnegated on the other side. That's 2. And the third thing, and this is the bit that's slightly trickier, if the propositional function is negated on one side, it becomes unnegated on the other. If it's unnegated on one side, it becomes negated on the other. But look what the propositional function is now. This is really the only extra level of complexity for the application of these QN rules in relational predicate logic. We get multiple quantifiers, 2, maybe 3 place predicates. So look, this is what you've got. See how here, see the chunk. Notice the chunk that stays the same. There exists a y, not fxy. There exists a y, not fxy. That remains the same. Okay, so what's changed? It's just the not exist an x becomes, for all x, not. Right? So it is, as it were, that this, you are to think of that circled part as the propositional function, which stays the same through the transformation. It's just that on the first, second, on the third change, since it is unnegated on the left, becomes negated on the right. Right? Here it gets a negation. Right? Quantifier changed from existential to universal. The quantifier was negated on one side, it becomes unnegated here. And third, the propositional function was unnegated, it becomes negated, right? No negation here, we add a negation here. So that's always the move, right? It's always from, right? The move was just this, right, to this. Putting a bracket there, it's actually a quantifier in the brackets, right? But that's the move, right? 1, 2, 3 changes, okay? And it's the same thing every time, right? When you're running these through. Okay, so that's what you get. Okay, other crucial point of information. QN rules are replacement rules. They are like the rules from Unit 8 in the bottom half of the inside cover of your Klenk text, and that they're replacement rules, which means the left and right hand side of every QN equivalence are logically equivalent formulas. It's not just a relation of logical implication, like the Unit 7 rules of inference. It's a relation of logical equivalence, which means two things, of course. Remember from Unit 8, this is the whole lesson from Unit 8 was, these are replacement rules. They have this different relation between the two. Therefore, there are two differences in application. You can not only go from the left-hand side to the right-hand side, which is all you could do for the rules of inference from Unit 7. You could also go from an instance the right-hand side to the left-hand side. So you could go from this to this to this to that, if you so wanted. Notice if we were going from here to here, we'd be going from quantifier form out of quantifier form, which you may have use for, right? If that's the antecedent of a conditional. Oh, say this is that's a consequent of a conditional. You want the negation of that, so you can do a modus tollens. That would be a reason why you might go from there to there. But most of the time, you're going to be moving from negations to quantify form. So you can instantiate, like I said at the beginning of this video. But the second important thing you're allowed to do, because they're replacement rules, because the QN rules are replacement rules, is apply the QN rules to subformulas. So look how that comes out now. Here, I'm applying the QN rule to the subformula, this thing. Okay? And what have I done? I've just done the 1, 2, 3 changes. Very simple, right? Look what happened. Quantifier changes from existential to universal, that there exists a y, such that becomes for all y. Negated here becomes unnegated here, right? So it puts these things next to each other with no negation separating them. And thirdly, I've added a negation to this, right? So you could say, in this move here, which is the first one Klenk does, right? You're treating that as the propositional function without a negation, and you're adding a negation, right? But you could also, you would not make a mistake if you did the same, right? Oh, since if you thought of that as the propositional function, it is negated, so I'll remove a negation, and it is a perfectly legal QN to go straight from here to here. Okay, so various paths from here to here. One is QN to that, and of course, you know what gets from that to that? Double negation, right? Double negation on that subformula, perfectly legal. That's right, double negation is a replacement rule. You can go straight from here to here by QN. That would be an application of these extra forms that she mentions at the bottom of, not at the bottom, but of course on 324. At this page, she gives you these other forms. Of course, we have two other forms of the rule which can be stated as follows. Not for all x, not phi x goes to there exists an x, phi x. And the equivalent other one, right? So here, right, the not, notice that if I'm going straight from this one to this one, that just becomes for all y, right? Got rid of that one, it's negated here, so I unnegate, negated here, I unnegate, and the quantifier changes. So you can go straight from